Alright, welcome back to another video on my channel, math_exe, and today is another bonus video type video, I guess. And today we're going to prove the area of a square, which may sound dumb, but today we're going to look at an interesting strategy of proving some statements, and that is called, I'll just write that right here, proof by induction. And what exactly this is, and I will tell you later. And I'll just tell you the general things of this area of a square. So it's pretty self-explanatory. If you have like a square with side s, then the area will be s squared, which is the length of its side squared. So I'm going to use the proof by induction, and first you need to consider the claim that you want to prove. So I'll just put the claim, and I'll write area of a square. And next we're going to look at the base case, and we'll assume to assign a variable of a side, so we'll just choose n. So we'll just say s equals n, and the area will be just n squared. That's self-explanatory. Well, you may think that, well, this doesn't seem any good, so however the next step will be very interesting. So we're going to set up an induction hypothesis. Now what this means is we want to try to assume for all n, and then this area formula will be true for all such, let's just take s equals n plus 1. So in this case our area will be just the side squared, which is just n plus 1 in the parentheses squared. There we go. And next we're going to just do this in another perspective, and let's see what we have. So first let's try to draw a square with sides n plus 1. And yet this is not really a precise square, but just assume it is. So yeah, so we have our side lengths n plus 1 and n plus 1. Now what I'm going to do is I'm going to cut a part out of this square like so, and then I'll do this another one right here, such that this length right here is 1, and the same thing right here. So what that tells us is the remaining length of this is n plus 1 minus 1, since we take out 1, which is just n, and we have this n. And this is just a square. This whole figure, I'll just shade it in green, this is n squared. What I mean is the area is n squared. So we can just set up a expression. So we'll just write out n squared first. And next thing, to make this a square, we need to calculate these areas right here. So first I'm going to do this one. Since we know this side is n, I'll just write that right here, and the width is 1. This is a rectangle of length n and width 1, and therefore the area is n. So we just add n right there. And let's do the same right here. So given that this side is n right here, so this is the same, this is just n, and we have a width of 1, so therefore the area is n. And finally we have this small bit right here. We have our length of 1 right here, and our width of 1. So it's just 1 times 1, which is just 1. So what we'll do is we need to ensure this is equal to our original assumption of our area. So notice that we can combine like terms right here. So we have n squared. N plus n is just 2n plus 1. And you might not know what to do at this point, but notice that this expression is a perfect square. I'll just write PS for perfect square right there. So I'll just erase this because I need some space. Okay, so note our factoring of squares formula. And we can just do this by computing the square trick. So we can just set this equal to each other, so we can get that our a is equal to positive n. We're just going to take the positive version of this and substituting that in, so we can get our b is equal to 1. And then if we substitute b into our b squared, this is exactly the same, equal to 1. So we're good for using this factoring right here. So we're left with a plus b, which is n plus 1 and then squared, which, if you notice, this is exactly the area that we have gotten right here. So if we're done with this, we can just draw a box here, so we can assume that we're done with the proof. So I would do another one probably next video about this type of stuff, about the proof by induction type, because if I'm just going to do one video, it won't make very clear sense. So that's it for today, I guess, and hopefully you guys you enjoyed this short video. Please subscribe for more videos because I'm uploading daily. And as always, thanks guys for watching.